Welcome to the deep dive. You've brought quite the stack today. Insights pulled directly from Jensen Huang's GTC 2025 speech.
Ah, yes, GTC 2025. They often call it the Super Bowl of AI, don't they?
They do. And looking at this material, well, you can see why. It's really packed with a vision for where AI and computing are headed.
Definitely. A lot to unpack there.
Absolutely. So our mission for this deep dive really is just to pull out the most important nuggets of knowledge about the future. AI, computing, infrastructure, based only on this source material. We want to guide you through the key shifts.
And maybe some surprising facts presented there.
Exactly.
All right, let's dig in.
Okay, so let's unpack this. The source traces a pretty clear evolution of AI. It starts maybe, what, a decade ago?
Yeah, about 10 years back, the focus then was largely on what they call perception AI.
Right, like computer vision, speech recognition, teaching machines to understand inputs like images, sound.
Literally seeing and hearing the world, yeah. Then maybe the last 5 years, things shifted dramatically.
Towards generative AI.
Exactly. This is where the AI doesn't just recognize, it creates. It can translate things, text to image, text to video, even predict, complex stuff like chemical properties from amino acids.
And the source really highlights a fundamental shift here, doesn't it? We're moving past just retrieval computing.
Right, retrieval is like you ask a database a question, you get a pre-stored answer back. Simple fetch.
But with generative computing, the AI gets the context, the meaning of your request, and it generates something new, a novel answer, maybe pulling in some retrieved info, but building on it.
It's not just fetching something old, it's building something new. And what's interesting is this evolution, it's not stopping. The source talks about the next waves. Already here, really.
First up, agentic AI.
Agentic AI. It adds, well, agency, it perceives context, sure, but the key breakthrough they highlight is its ability to reason.
Reason. So it can think about how to tackle a problem, break it down.
Yeah, and then plan a sequence of actions.
Yeah.
And because it understands different info types, text, images, maybe video, you can use tools.
Like browse a website, watch a tutorial video, learn from it, and then use that.
Exactly. That ability to reason is positioned as the core thing here, the defining capability for this agentic wave.
And then there's physical AI emerging right alongside it.
Physical AI. This one gets the physical world, friction, inertia, gravity, cause and effect, object permanence. It understands 3D reality.
And that understanding unlocks advanced robotics.
Precisely. The source emphasizes that each of these waves, perception, generative, agentic, physical, they all open up totally new market opportunities, fundamentally changing what computing can even do.
Okay, but enabling these increasingly complex AIs, that takes solving some deep problems, right? Yeah. Foundational stuff.
Definitely. The source lays out 3 big challenges driving things now. First, the data problem. AI needs just massive amounts of data, digital experience to learn well.
Second, the training problem. How do you train these complex models without humans in the loop all the time? It needs to learn way faster at superhuman scales.
And third, the scaling problem. Finding those algorithms where, more compute equals smarter AI. That scaling law.
So given those challenges and these new capabilities like reasoning, what's happening with just the sheer amount of computation needed?
Well, this is where the source drops a really surprising fact. The computation requirement. Driven by that scaling law, it hyper-accelerated dramatically just in the last year.
Hyper-accelerated? How much are we talking?
The estimate now is easily 100 times more computation than they thought was needed just 12 months ago.
100 times. Wow, that's a staggering jump. What does that even mean for infrastructure, for costs?
Massive implication.
Yeah.
Huge. And the source explains why this happened. It points straight at the rise of reasoning in agentic AI.
Because reasoning isn't just guessing the next word.
No, it's breaking a complex problem down, step by step, checking intermediate results, building towards an answer logically. Think chain of thought, consistency checking.
Right. Unlike older models that might just confidently state something totally wrong.
Exactly. And this step-by-step process, it just fundamentally changes the compute demand. Instead of one final output, the AI generates tokens for step 1, uses that as input for step 2, and so on.
So many, many more tokens generated overall.
Substantially more. The source suggests easily 100 times more tokens per query compared to simpler models.
And for it to feel fast, for low latency for the user, you need to process all those extra tokens much, much faster.
Right. So if you have, say, 10 times more tokens and you need it 10 times faster to feel responsive, well, 10 times 10 is 100 times the computation, roughly.
So the bottom line is inference computation, the AI actually doing its work in real time, is just dramatically higher than anyone expected.
Way higher. A huge jump.
Okay, so inference needs way more power. But how do you even train an AI to do this complex reasoning?
Good question. The source highlights a major breakthrough there, too, in training methods. Reinforcement learning with verifiable results.
Instead of just human examples, which are slow and limited.
Exactly. You use problems where you know the right answer or process. Math problems, logic puzzles, scientific principles, things you can verify. Hundreds of these domains.
You can generate millions of examples.
Millions of unique problems. Then you let the AI try to solve them hundreds of times, step by step. And you use reinforcement learning, RL, to reward it as it gets closer.
And each attempt generates tokens. Lots of tokens, if it's reasoning.
Tens of thousands, potentially. So hundreds of topics, millions of examples, hundreds of tries. It adds up. You need trillions and trillions of tokens just for the training data.
Wow. So agentic AI reasoning plus this new training method, that's what's driving this insane computational demand.
That's the core driver. And the source shows how this demand is fueling a massive build-out.
Right. This explosion in demand leads to huge infrastructure investment. The source mentioned analysts forecasting global data center spending hitting, what, $1 trillion soon?
Trillion, yeah. And the source emphasizes the vast majority of that growth. It's shifting towards accelerated computing.
It's a real platform shift, isn't it? Moving beyond general-purpose CPUs.
Definitely. To running machine learning on accelerators, GPUs mostly, it's not niche anymore. It's becoming the dominant way.
And they introduced this concept, AI factories.
AI factories, I like that term. They're not just storing data. They're purpose-built to generate these valuable tokens, transforming them into music, words, video, scientific discoveries.
It's a shift from retrieval centers to generation factories.
And what's fascinating is the acceleration isn't just for the big AI models themselves. The source makes it clear. Everything modern will eventually be accelerated, including lots of scientific and industrial tasks.
That's where the CUDA-X libraries come in.
Right, over 900 of them. Highly optimized software frameworks, all built on CUDA. They accelerate specific fields, physics, biology, math, simulation, you name it.
The examples given were pretty impressive. Calitho.
Yeah, for computational lithography. Basically a virtual factory running alongside the chip fab using AI and math to design those complex chip patterns.
And Ariel, turning a GPU into a 5G radio.
For AI-powered wireless networks, AI RAN. Then there's QOpt for numerical optimization. Things like logistics, supply chains, now open source too.
MONAI for medical imaging, Earth-2 for weather.
The list goes on. And the key thing the source highlights is the reach of CUDA itself. 6 million developers everywhere. Cloud, data centers, vendors.
So these specialized libraries mean huge speed-ups for applications in those fields.
Incredible speed-ups, which leads to moments like that anecdote they share, the scientists completing their life's work in my lifetime.
That's powerful. Really shows the impact beyond just business.
Absolutely. And this tech, starting in the cloud factories, it's moving out into enterprises, manufacturing, robotics, and out to the edge.
Ah, yes, the edge. That seemed like a big focus.
A really big focus. They announced major partnerships, T-Mobile, Cisco, Cerberus, ODC, building a full-stack platform for radio networks here in the U.S. That's a massive industry, $100 billion a year.
The idea is to put accelerated computing and AI right into the comms infrastructure at the edge.
Exactly. Use AI, reinforcement learning, to adapt complex radio signals like massive MIMO dynamically, make them more efficient, react to real-world conditions faster.
Like how humans use context to communicate better.
That was the analogy, yeah. AI adds context and intelligence to optimize the signals. Makes them more robust.
The source also talked quite a bit about autonomous vehicles, AVs. They've been in this for a long time.
Over a decade, yeah. Since AlexNet, basically. Providing tech to most AV companies.
And the big partnership mentioned was with GM, building their future self-driving fleet.
Right, and it's not just AI in the car. It's AI for manufacturing, for enterprise design and simulation, and the driving AI itself.
They also really hammered the point about safety, didn't they? Calling it halos.
They did. Emphasized it rarely gets enough attention. It's their whole approach. Silicon, software, algorithms, methods, everything focused on safety.
Mentioned being the first to have, 7 million lines of code safety assessed by third parties?
Yeah, and over 1,000 patents just on safety philosophies, diversity, transparency, explainability, clearly foundational for them.
And building these safe AVs involves using AI to create AI.
Pretty much. They talked about Omniverse and Cosmos for simulation, model distillation teaching a smaller student model from a big teacher model.
And closed-loop training. using real-world driving data.
Right, taking stuff that happened on the road, good or bad, and using it to automatically create realistic 3D simulations in Omniverse, then testing the AI in those sims.
Plus synthetic data generation, using Omniverse to build digital twins, then Cosmos to scale out tons of diverse scenarios.
Exactly, generating situations that might be rare or dangerous in the real world. The goal they stated is closing that sim-to-real gap, making sure AI trained in simulation works safely in the real world.
Okay, let's shift gears to the core data center stuff. The hardware needed for all this. They spent a lot of time on the new Blackwell architecture.
Yeah, fundamental transition. And a key idea was scaling up first, making one unit incredibly powerful before you scale out by connecting lots of them,
Because scaling up is harder.
especially when you need extreme power efficiency. So the Blackwell system has disaggregated NVLink.
NVLink being the super fast connection between GPUs.
Right. Disaggregated means the NVLink switches, the traffic controllers, are separate from the compute nodes. This allows for a liquid cooling and just insane density.
Like an exaflop computer in one rack.
One exaflop, a billion calculations per second in one rack, weighing 3,000 pounds, 600,000 parts, 5,000 cables. It's nuts.
And this density is needed for inference at scale, the main job of the AI factory.
Exactly. Generating tokens, answering queries, doing tasks in real time. That's the core function, directly tied to service quality and revenue.
They explained a tension there, right? Between responsiveness for one user and throughput for the whole factory.
Yeah. You want high tokens per second per user that makes the AI feel fast and lets it do more reasoning steps, making it smarter. But you also need high overall throughput total tokens generated across everyone for volume and profit.
And the workload changes, from thinking to generating.
Right. Prefill is the initial thinking, digesting the prompt that's heavy on computation, flops. Then decode is generating the response token by token that's more limited by data movement, bandwidth.
Yeah.
It shifts dynamically.
And managing all that is Nvidia Dynamo, the OS for the AI factory.
That's how they described it. Built to manage these super complex dynamic workloads across the whole system, orchestrating billions of tokens. They mentioned it's open source. Partners like Perplexity are using it.
And they showed simulation results. Blackwell versus Hopper.
Yeah, supercomputers simulating future supercomputers. Comparing Blackwell NVLink 72 with Dynamo to Hopper on an equal power basis. Blackwell was dramatically better for reasoning models.
How much?
40 times faster token generation for the same power, and a 25 times overall improvement on that ISO power metric. The analogy was like a factory where the more you buy, the more you make, really bending the performance curve.
They also laid out a pretty aggressive hardware roadmap. Annual product, biennial architecture.
Super aggressive. Blackwell's in production now. Then second half of 2025.
Blackwell Ultra, an enhancement.
Right. Then second half 2026, the next big one, Vera Rubin.
Named after the astronomer. Nice touch about her grandkids being there.
Yeah. And this is a major architectural leap. New CPU, twice as fast as Grace. New GPU, new networking, CX9. New NVLink, NVLink 144. New HBM4 memory.
Everything but the chassis is new, they said, to manage risk.
Seems like it. A huge jump. And they clarify that NVLink number NVLink 144 means connecting 144 GPU dies at top speed.
Okay. And after Vera Rubin.
Second half 2027 brings Rubin Ultra. This is like extreme scale up again. NVLink 576 connecting 4 times more GPU dies.
Leading to
15 exaflops scaled up performance compared to Blackwell's 1 exaflop. Massive jump in bandwidth too. Even higher density, 600 kilowatts per rack, 2.5 million parts.
they showed a chart, right? Hopper as 1x.
Blackwell was 68x.
Yeah.
Rubin jumps to 900x scaled up performance. The pace is just incredible.
And it's not just raw performance, it drives down costs, too.
Right, the total cost of ownership efficiency metric, flops, times bandwidth divided by power. Rubin is projected to significantly improve that, making AI compute cheaper per unit, even as it gets more complex.
Okay, that's scaling up. What about scaling out across the data center, connecting potentially millions of GPUs?
That's InfiniBand and Spectrum-X networking. And the key technology there is advanced silicon photonics.
Because traditional electrical connections use too much power over distance.
A lot of power. The example was 1 million GPUs needing 180 megawatts just for the signal connections with older tech. Energy is the critical commodity. Networking power can limit your compute power.
So NVIDIA's solution is co-packaged optics, CPO.
Yeah, the world's first 1.6 terabit per second CPO silicon photonics system. Using light, photons, instead of electricity right off the chip. Uses tiny micro-ring resonator modulators developed with TSMC.
And the benefit is Huge power savings.
Tens of megawatts saved across a big data center. That energy can go to more compute. It enables massive scale-out networks with high-rated switches connecting way more components directly.
And that tech is coming soon.
Silicon photonics switches later this year, 2024. Spectrum-X platforms with CPO in the second half of 2025.
Wow. Okay, so beyond the hardware infrastructure, the source argued AI is reinventing the whole enterprise stack.
The entire thing, processor, OS, apps, orchestration, even storage, everything.
And they introduced this idea of AI agents as a digital workforce working alongside humans.
Yeah, like moving from maybe 1 billion knowledge workers today to potentially 10 billion digital workers, powered by AI. They even predicted 100% of software engineers will be AI-assisted soon. Nvidia is aiming for end of 2025 for themselves.
And new computers for this era, like that workstation.
The DGX Station Spark. Desktop form factor, but series power 20 petaflops AI, 72 CPU cores, HBM, PCIe for adding maybe a GeForce card. For data scientists, researchers, right on their desk.
And maybe the biggest shift, storage.
Yeah.
Moving beyond files.
Yeah, a really profound change described, from retrieval-based to semantic-based retrieval and storage.
So storage systems will actively process data, turn it into knowledge.
Continuously, in the background, embedding raw data into structured knowledge. So you don't search for files by name anymore.
You just talk to the system, ask questions about the content, give it problems.
Exactly, like talking to your entire data set the way you talk to Perplexity or another AI today.
And this future storage will be GPU accelerated.
Absolutely. They mentioned a broad partnership with all the major storage vendors working on this. Dell, HPE, IBM, DDN.
Okay, so let's try and synthesize all this. What does it all mean? It's quite a journey the source lays out.
It really is. Starts with the evolution of AI, from perception to generation, reasoning, understanding physics. Each step creating new markets.
Then the massive, surprising jump in computation needed, driven by reasoning and new training methods.
Which fuels this huge global build-out of AI factories using accelerated computing. Not just for core AI, but accelerating science and industry via libraries too.
And AI moving out from the cloud to the edge, changing communications, enabling AVs with a huge focus on safety.
Underpinned by this incredibly fast hardware roadmap, Blackwell, Rubin Ultra, driving scale-up performance like never before.
Plus the critical networking advances, silicon photonics, enabling efficient scale-out.
And finally, this fundamental reinvention of the whole enterprise stack. AI agents as workers, storage becoming semantic knowledge systems.
The big themes seem to be retrieval to generative, general purpose to accelerated, file storage to semantic storage, human training to RL synthetic data, air-cooled to liquid-cooled, integrated to disaggregated, human workers to human plus digital agents.
Yeah, and it's all interconnected. Hardware, software like the libraries and Dynamo, the vertical solutions, all working together, all aimed at generating tokens more efficiently, more intelligently.
And it connects back to you, the listener, because this isn't just about chips. It's about enabling a future where AI reasons, understands the physical world, maybe changes every industry.
And accelerates discovery, like that scientist's life's work in a lifetime. That's the potential promise here.
Well, that brings us pretty much to the end of this deep dive into the GTC 2025 source material.
It's definitely a vision of computing scaling at a pace that's, well, almost hard to grasp.
It really is.
Yeah.
So maybe a final thought for you to ponder. If we take this scenario seriously, a world filling up with billions of these AI agents, digital workers, collaborating with us, changing how we even interact with information, what new things become possible, what challenges pop up that we haven't even thought of yet. What does it feel like when your entire enterprise data is something you can just talk to?
A lot to think about for sure. Definitely food for thought.
Thanks for joining us for this deep dive. We hope it's given you some valuable insights from the material you brought.